Hey guys, welcome back to the channel. So for this video, I had one of my friends attempt to solve the Leetcode problem with a follow-up problem. This friend goes by the name of Xavier. Xavier has recently started his journey as a software engineer at Google. To you, Xavier. Quick disclaimer. Xavier has not touched code in about 10 months. But Xavier still demonstrated that he followed good study habits because he was still able to tackle the problem with a positive mindset, and eventually he came up with a solution for the problems. If you guys like this type of content, please let me know so that I can make more videos like this. Also, if you guys are not subscribed, please go ahead and subscribe. If you find this video intriguing, go ahead and give it a like. And go crazy in the comments. Ask any questions about the problem, and I'll be sure to answer. All right, so let's get to the video. Okay, Xavier, can you hear me?
Yes.
Okay. Okay. How's it going?
That's it.
That's good. That's good. All right. So, just go ahead. I know you, but just go ahead and tell us a little about yourself. The people on my channel don't know.
Okay. Hello, I'm Xavier Lamphere. I will be starting at Google soon with Lou over here.
Good. All right. So, that's all really. Let's just get straight to the problem. Okay. So, I have a problem here. So, do you know what an anagram is?
Yes.
Okay.
It's a letter mixy up thing.
Exactly how I feel it. So, Javier. I am dying.
Yeah. So an anagram is a letter jumble puzzle. Like you take a bunch of letters, you throw them into a bag, you shake them up, and you come out with a mess, and those are anagrams.
Okay. All right. So, this problem here, problem 242 of Leetcode, if you guys want to look it up or go try it on your own. It's called Valid Anagrams. So basically, given two words, you have to see if the two words are either the same or different permutations of each other. So, Xavier, say I have car and RAC as two different words. They would be a valid anagram because if you switch the letters around, you would get the same things. So, this problem, you're just gonna figure out if the two words or the two strings in this case are valid anagrams. And Javier has chosen to do this problem in Java. For you guys who don't know Java, maybe it's a good time to start to learn from this. But this is not very complex. This is just the easier problem, and then we'll move on to a harder problem after this one.
I'm gonna preface a couple of things here. I have not worked in Java actively in months, actually since before the interviews that we went through for Google. So this is gonna be my first time touching Java in quite a while. It was my main programming language for several years though, so I expect this to not be too bad to pick up. Yeah, that's basically it. So Java is a language that's full of boilerplate, so I'm just gonna put a couple things I'm going to need. I know here. Import java.util.star. This is not a good thing to put. Oh wait, does Leetcode already do imports for you?
Yeah, they do.
Oh, I'm ignoring this. In the traditional Google interview, you do it in a shared document, so you have to do all the imports yourself.
Yes.
So I was gonna say, don't do this unless you're like strapped for time or something, and if you do, explain it. Because in Java, technically best practice is to not do star imports and instead to import specifically the classes that you know you're going to be using.
Yes.
There's that.
Very, very true.
So anagram is a shaky up thing. So it was already said before that if I have something like car, then its valid anagrams would be, there's 6 of them. I know this off the top of my head, but if I had CA, because I don't want to enumerate 3 letters, then my only other valid anagram would be RC, because it uses the same letters. If I had, say, CRC, it gets a bit more complicated, because this is a valid anagram, and this is a valid anagram, and it takes you a second to think about that. Do the order of the C's matter? No, they're just C's. They're not special anyway. So you need to start thinking about how to deal with that. And the way I see it, there's basically exactly 2 solutions. 2 solutions that wouldn't drive somebody insane, and one of them might still take you halfway there. The first one would be to do something like enumerating all of the various orderings of all of the letters in the word, and then checking all of those against what you have. And that would be a sort of like combinatorial solution where you'd write an enumerator that would enumerate over the various different letter groups, and then through those different letter groups produce all orderings of all the letters in the word. And you could do that. And that is probably what the brute force solution for checking for an anagram would be. And you should never do that, because it is harder than the good solution. I'm going to call it the good solution because I don't know what else to call it. And I could sit here and write an enumerator, and that'll take me like an hour to do that, because writing an enumerator for that, writing a enumerator that would take all letter groups is insane. Harder when you're not in English, by the way. So there's a much simpler solution, and you do something sort of like you take like buckets for each letter, and you just count how many letters there are of each letter there are for each bucket.
So like a frequency table.
Yeah, that's exactly what you'd call it. You'd call it a frequency table, or a frequency lookup, or something like that. You're checking the frequency of each letter. Technically, the count of each letter, but you could directly correlate count to frequency based on the length of the word. So yeah. See if I remember how to declare an array in Java. Int word array. Camel case. We use camel case in Java. I've been using Python for like the last 10 months, and I gotta think back through and change all my naming schemes when I'm doing this. It's gonna take me a second. 26 letters in the alphabet. Have to use semicolon. I have my bucket, my frequency list. I'm calling it my word array because it's going to basically count how many, what the frequencies of the letters are in my given word that I want to compare against. So in this case, S is going to be what I consider my word of truth, and then T is what I want to see if it matches. Technically, I could do it in either direction because I'm really just seeing if they're anagrams of each other. Because if A is an anagram of B, then inherently B must be an anagram of A.
Correct.
But I don't need to. I also don't really need to specify which one is which. I'm just doing that for a mental state, so I know where I'm starting and where I want to end up. Now I need to effectively I need to count. Well, okay. Easy base case, real quick, because I can do this and it works perfectly fine. If I believe in Java, strings have this that I can use. I've got.
What is that doing?
So what this is doing, this takes the length of string S, checks it against the length of string T. If they aren't the same length as each other, they're not anagrams of each other. Just how it's got to be.
Yeah, it can't be.
Yes, lowercase in Java. Good. easy base case out of the way. Technically, it doesn't change like the running time complexity or anything, but just have it up there for the sake of it. I'm gonna write it one way, and then I'm actually gonna make a small modification to it. That is the main reason why I put that thing up there in the first place, and so it's not really gonna make sense for why I want that there until after I get through my second pass of improving the problem. Sorry, like I said, I've not necessarily solved this exact problem before, but I've solved problems like it, so I know the solution steps that I'm going to end up going through ahead of time. Sorry for like giving you spoilers about what I'm going to end up doing.
No, you're
good. So I want to prime this, or not prime it. I want to fill this with what my frequencies are, as you called it. So declare. So I'm gonna prime this with the thing. So if I'm remembering my array declaration in Java, you actually do give it a variable, you instantiate it, you say what's your my loop conditional, which in this case is going to be I is less than s dot length, and then my loop and doey thing. So each iteration I want to check the character s dot char, or actually no, I don't want to check the character. I want to count that character in the array. So I want to get w array location is going to be char. So in Java, single quotes means char. So I'm just treating this single character as a char. I can't put like multiple characters in here. That'd be a string. I'd have to use double quotes, single quotes specifically. Chars are inherently treated like integers, so you can like subtract chars from each other. So this is one of the easiest ways in Java to get what letter you have out of a char, and that's
what number.
Yeah, what number it is. I just realized I'm not guaranteed. Okay, yeah, I am guaranteed. Only lowercase. I'd have to do something more complicated and something way more ugly if I wanted to get numbers out of uppercase. No, I wouldn't. I would just cast them to lowercase actually, because I could do like s dot lowercase dot char at instead, but I don't need to do that. S dot lowercase dot char at I. This will give me a position in the array. If it's an A minus A gives me 0. If it's a B, A minus B gives me
-1.
So I need to use Z here, not A. I like using A though, so I'm actually going to subtract A from it instead.
Okay.
Because I like A more than Z.
You prefer A's.
Yeah, you can subtract Z from it, this from Z, or A from it. Works both ways. It works the same way either way. This is just what I would prefer to do in this case, and in most cases.
Yeah.
So this will give me a position, the position of whichever character I'm currently at in the loop. Given that I'm going to, and this will give me accessing that point in the array. The array I'm really treating as just like as mentioned before, a store of how many characters of an individual character have ended up in that string. I need to actually increment it though. Done. Incremented it. So this will now this is basically a footprint, an anagram footprint of whatever I got in S. I just do that a second time for T. C array for copy array. I'm gonna type it out. I always hate when I look at code and it's not like descriptive what the words mean. So I'm changing things now because, yeah. I'm changing it again. This is S array. And this is T array because those words sucked. Need to change this to T. Need to change this to T. T.length. T.char I. ... And then all I need to do is see if the arrays are equivalent to each other. I think there's just like a function that's like array.equals. So SRE, TRE, I have caps lock on. That will fail. Array.equals s return. I want to return this. So I'm going to test run this. I'm relatively confident this will work, and there are no compilation errors, but we'll see.
All right.
There's a compilation error. I forgot how to instantiate arrays in Java. Yay! So, I mentioned here that I had put this up here for a reason. I'm actually going to... So, the running time complexity is going to be the same, and in fact, I'm willing to bet that the compiler optimizes this out anyway. Trying to be more clever than your compiler can often actually lead to issues, but I'm going to actually do both of these in the same loop because I can. Because I've verified up here that they're the same length as each other. So while the running time complexity is going to be the same, barring any compiler optimizations, which I assure you, the compiler is much smarter than you are most of the time, this is probably going to be actually basically the exact same footprint. But I can do this. Get rid of this loop entirely. Run it, and it should work.
Yes, indeed. Yes, indeed.
This is I've clicked over to this tab a few times. This is really just the warm-up problem because we actually have a slightly different problem that Lou brought to me to do. Anything we want to bring up on the previous problem before we move forward?
So what would the time complexity be of a problem like this or a solution like this?
The time complexity of this problem is going to be O of S or O of T, whichever is larger. But you just say for when you have like something that's or, you generally just say one of them and whichever one. You generally just say one of them, whichever one you believe is going to be the larger one. Because generally in the problem description, you're actually going to know which one is going to be larger. So in this case, I'd say it's O of S. And space complexity is going to be the same thing because space complexity isn't always brought up, but you might as well discuss it. It's just how much memory this takes up. It takes up the size, the space of an array. Once again, I assume S is large, but in this case, it's O of 1 space complexity because my array is just 26.
Yeah, and 26 is a constant, so it's just always going to be 26. So it's O of 1. Constants are O of 1s.